Have you ever wondered how a jellyfish moves so gracefully, how soap bubbles form perfect spheres, or how flexible robots and wearable devices mimic the softness of human skin? All of these mysteries, from nature's elegance to next-generation technology, come together in one fascinating branch of science, soft matter physics. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore how the physics of the soft, the flexible, the adaptive, and the living, is shaping the future of materials, robotics, and human-AI interaction. You can watch the entire physics playlist by clicking the link in the description below. This topic belongs to our section Matter, Materials, and the Rise of Technology, where we uncover how the structure of matter drives innovation, from quantum chips to living machines. The physics of the flexible world. Unlike the hard and rigid materials we often study in classical mechanics, like metals or crystals, soft matter refers to materials that easily deform under small forces. These include liquids, gels, polymers, colloids, foams, and biological tissues. They sit at the intersection between solid and liquid, materials that can flow, stretch, bend, and self-heal. Think about the softness of human skin, the stretch of a rubber band, the smoothness of paint, the elasticity of living cells. All these systems behave in ways that are complex yet beautifully coordinated. Soft matter physics explains how molecular structure, thermal motion, and external forces combine to create these versatile behaviors. The hidden order of softness. What makes soft matter so fascinating is its collective behavior. Millions or billions of molecules work together, rearranging, flowing, or forming patterns, often without any external control. A soap film, for example, naturally minimizes its surface area, forming perfect geometric structures through a simple principle, energy minimization. A liquid crystal, the same technology used in your smartphone display, can align itself under an electric field, changing color or transparency in real time. Soft matter often exists far from equilibrium, constantly responding to forces, heat, and motion. That makes it a powerful model for understanding living systems and adaptive materials. It's the physics of how matter feels and behaves, not just how it moves. From a living matter to living machines. Soft matter physics doesn't just explain life, it's helping us recreate it. By combining physics, chemistry, and biology, scientists are designing materials that mimic living tissue, materials that can stretch, sense, and even heal themselves. This research is transforming technology in areas such as flexible electronics, where devices bend, fold, and stretch without breaking. Soft robotics, where robots made of gels and polymers move like living creatures. Wearable sensors, that interface seamlessly with human skin. Artificial muscles, that contract and expand using soft, energy-efficient materials. In the future, your AI-powered devices may no longer be rigid boxes of metal and silicon, they could be soft, responsive, and physically intelligent, able to adapt to you like a second layer of skin. Soft matter and human AI interfaces. One of the most exciting frontiers of this field is the development of human-AI physical interfaces, where soft matter bridges the gap between humans and machines. Imagine robotic prosthetics that move naturally and feel lifelike. Imagine soft wearable devices that monitor health by gently sensing body signals. Or AI-driven materials that respond to touch, temperature, and pressure, just like biological tissue. Soft matter physics provides the blueprint for these innovations. By understanding how flexible systems dissipate energy, transfer information, and adapt to stimuli, we can create machines that feel the world, not just compute it. The future of soft physics. Soft matter physics is more than just a branch of materials science, it's a philosophy of adaptability. It shows that strength doesn't always come from rigidity, sometimes, it comes from flexibility. In the coming decades, this field will be central to sustainable and recyclable materials, medical implants that integrate naturally with the human body, smart clothing and responsive environments, AI-driven materials that learn from their surroundings. By studying softness, we're not just improving machines, we're bringing technology closer to life itself. Why it matters. Soft matter physics connects the human, the natural, and the technological. It's the science that allows machines to become more organic, materials to become more intelligent, and interfaces to become more human-centered. It reminds us that physics isn't only about stars or atoms, it's also about the texture of life, the fluid, the flexible, and the fragile systems that make our world dynamic and alive. This is the Learning Studio, and this was our episode on soft matter physics. If you enjoyed exploring how flexibility and form shape the future of technology, make sure to like, subscribe, and check out our physics playlist linked below. In our next episode, we'll move from the world of soft, adaptive materials to the thermodynamics of computation and entropy in information theory, where we'll explore how information itself follows the same laws of energy and order. Because in physics, even softness has strength, and even flexibility follows the laws of the universe.